This is lesson 1.2, graphing linear systems. There may be additional notes to find on Edline or a video in the future. At the time of this recording, though, I do not have an additional recording or notes from the instructor. So I'm going to demonstrate right from the independent practice page how to solve systems of equations and graphing them. Okay. So with systems of equations, these are two equations that you're going to graph on the same coordinate plane. Where they intersect is the only solution to the equation, if there is a solution. So I'm going to demonstrate the first problem with you. Both of these equations are in slope-intercept form, and that's your first step, is to make sure that all equations are in slope-intercept form. And then you're going to graph each equation separately. Now, to make it clear which equation line is which, I'm going to use two different pen colors. So for this first equation here, I'm going to go ahead and graph it in purple for you. I start with my y-axis at -8. And then I have a slope of -2/3. Well, if I go down 2, I can do that. And over 3, you should be plotting it right there. And then you'll draw your line. So there's the line for the first equation. Now I'm going to switch pen colors for you and graph the second equation on my coordinate plane. Again, I start with the y-intercept. This time it's +6. And using the slope of 5/3, so I go up 5, 1, 2, 3, 4. 5 is off the graph. So remember, if it's off the graph, all you have to do is go in reverse. So I'm going to go down 5, 1, 2, 3, 4, 5, and back 3, 1, 2, 3, and that should put you right about there. Right there. Okay, connect those two and draw your line with that. So there's my second line. Where these two lines intersect would then be your solution to this system. So a system just means more than one equation. So our solution is right here where it intersects. Now, it's to say that not all your lines won't always intersect. And if I drew my line very straight, so it is important that you use a ruler so that they'll be straight, you should be able to clearly see your solution. So my line is just a little off, but I think I can make out what the solution was supposed to be at -6, -3. So that is the solution to the equation, or to the system. Let's try another one for practice problem 2. Again, I'm going to use the purple for the first equation. Its intercept is at -4. The slope is 3/8, so I'll go up 3, 2, 3. That should take you at -1. And then over to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. Or I could have just looked at the 8. It's right there. Graph the line. There you go. It is very important that you extend the line all the way out and past the graph, because you never know where the lines are going to intersect. I see some students just make an arrow on each side of the points that they have plotted, and it's really not enough. You need to draw it all the way across the graph. So that was the first That was the first equation. Now I'm ready to graph my second equation. So my y-intercept this time is at +5. My slope is -3, 4. So I go down 3, 1, 2, 3, and over to the right 4. 1, 2, 3, 4. I have my 2 points. Now I graph the line. And then I look for my intersect. Right here this time, And I know my pen is covering up the numbers here so that what looks like at negative, or that's at positive 8, comma, -1. So remember, your solution is a coordinate or an ordered pair. So when it asks for the solution, you will need to write your solution as an ordered pair. Okay, I think you could probably take it from here. I'm going to look for one more example for you for one other type of scenario. So you can probably do the next 2 problems while you're working on that. You can push pause and push play if you get stuck while I demonstrate maybe one of the other problems on this page. Okay, I found the problem that I wanted to show you the example of for a different scenario. You still graph this the same way, but I just want to show you what the solution would look like then. So jump to problem number 5, and let me demonstrate this one for you. Again, I'm going to start off with purple to show you the graph of the first equation. So that has a y-intercept of -9. And a slope of +5, so I go up 5, 1, 2, 3, 4, 5, and over 1. Because remember, if you don't see a number below, it's just 1. And then I'm going to graph that line. Oops. Alright, and then I'm going to switch pen colors to blue to show you the second equation. This time the y-intercept is at +7. And our slope is 5 again, but if I go up 5, I go off the graph, so I need to do the opposite. So I go down 5, 2, 3, 4, 5, and back up 1 right here. Okay, and then I graph this. By the way, on your video, I apologize in advance if this looks tiny to you. The zoom wasn't allowing me to work very well on this. Yeah. Let me try that one again. It only lets me draw a straight line in one direction, so I have to do it twice. Alright, so try one more time just so that you can see what this is going to do. Yeah, that one's a better example. Okay, so take a look at these 2 lines. If they were absolutely straight, what we're trying to demonstrate that these 2 lines are parallel. They will never intersect. And if you remember from Algebra 1A, whenever the slopes are exactly the same sign and everything, then you will have those parallel lines. It's always parallel. So if you have parallel lines, that means they never intersect, and therefore the answer to your problem is no solution. Parallel lines do not intersect, and we know that an answer or a solution to a system is where they intersect. So there are no solutions to this problem. Okay, so we know that there's times when there's no solutions. There is one other type of answer you could have. If both your slopes are the same and your intercepts are the same, so basically you have the same equation, then you will have what is called many solutions. There's also another name for that. So ask your instructor how you would like to write the many solutions answer. I've seen different teachers do different things, and I'll try to maybe in another recording explain how Mr. Marks wants his. So let's recap how you could have different solutions. So when you're solving systems or 2 equations, you could either have one solution and then you would write it as a ordered pair. You could have no solutions, and that's when m of one equation and m of the second equation are the same. Or you could have many solutions when both slopes are the same and both y-intercepts are the same. All right. Good luck with the rest of this independent practice. Go ahead and complete the rest of the problems. If Mr. Marks wants you to go over your solutions, I will post also solutions to all the problems.